Teacher, we can't hear.
Yes, Daniela, just hold on a bit. The meeting is going to start soon. The teachers are joining shortly in a few. Let me see. When the teachers join, we shall be ready to go. Some people join faster than others. I wonder why. Okay. So let's just hold on a bit. Yeah.
This one.
Good afternoon, teacher. I greeted you, but you scanned me.
Good afternoon, Melissa. Well, I didn't hear.
Good afternoon. Teacher, it's Joan who greeted you.
John, sorry. Good afternoon anyway. I think the network is unstable, so I might have missed. I might have not heard, but I'm hoping you are all well.
Good afternoon, teacher.
Good afternoon. This is really taking long. Okay, Mr. Saint Jove, you're welcome.
So we are praying.
Amen.
Oh, sorry.
Amen.
Amen.
Thank you.
Amen.
Okay.
Thank you.
Thank you so much, Leila, for praying for us. Girls, Mr. Bato, you are saying something?
No, I was saying you're welcome. Over to you, really. I think I didn't hear
Okay.
some of what was going on. But yes.
Just cross-checking. Okay, I'm trying to cross-check names here. If I find any name that has no attachment to class, I am discontinuing you for security reasons and for keeping order. I hope you understand what we ought to do with our names, what we're supposed to do. We left a problem behind, or a question behind. Elizabeth Natabi. Elizabeth Natambi, can you unmute? Elizabeth Natambi. Elizabeth Natambi. Hey, Elizabeth Natambi doesn't want to talk to me. Okay. We want to go through that question and then we go to the new question that we are having in the whatever. Anybody who got a solution for the question left behind? Anyone who is ready to help us with the solution? Hello? Priscilla Sanyu, are you saying something? Priscilla Sanyu?
Teacher.
No, you are not saying anything. You don't have a solution. Who is Kirabo Maria? Kirabo Maria, Kirabo Michelle. You don't have classes attached. Eh? There are so many girls here. Kirabo Maria, Kirabo Michelle, Kira. Who is this one? Kirungamiza, something like that. Letitia. Eh? Hey, these girls don't want to proceed and go ahead. You are not answering questions. What is happening? We want a solution to the last question. Nabali Rona, I don't know you. You don't have a class attached. Nabasi, okay, Nabasi has attached a class. Nabali Rona. Nabali Rona.
Yes, teacher.
What is your class? Please attach your class to your name.
So let me attach it. It's plain.
Noella Isabella, you don't have a class attached. Is it Noella? Noella, see, no, it is Nimurunji Isabella. Paula Nyamwezi. Paula Nyamwezi, you don't have a class attached. Okay, girls, for us, we are ready there. If you are not ready to offer us a solution, we have to go ahead. So concentrate on the board. I hope you can see the board. You can see Teacher Javi writing that question, and I hope you have the question. Let's try to answer to that question, then we go to other questions that are going to help us as we progress. I hope you are seeing what is on the board. Is it clear to everyone?
Yes.
Okay. Yes. Okay. What did we do? We are supposed to find the weight W. The weight, the length of the road was given as 4 meters. So how do you label that road? How did you label in terms of distances? Okay, Lugolomi, please give us an answer. What do you do?
Charles is answering us. I was just saying that when we had taken a screenshot of the question, I didn't see the final question because it stopped on answer the question that follows.
Yes.
I posted the question.
So okay,
Charlene.
determine the weight.
I posted the question on, and I told you people to share the question. S2K, what happened? You are very selfish. I posted the question, you are whatever. I told you share, and there was a person who also, let me check my phone. Wave at you, eh? I will wave at you, Kali. Okay, the question. Now, Wama, I'm going to ask all the questions from 2S, and the rest 2K don't even bother putting up your arm. Back to you now. Okay. What is A? What is A? Label the distances, please. Label A as 0. We are assuming A is 0. So A and B will be. How long is the road?
4 meters.
4 meters. Okay. Is it a uniform road?
Yes.
If it is a uniform road, what do we know where the weight? Yeah?
Yes.
It didn't say it was a uniform road. It said the
Yes,
figure
it is.
below shows a metro road. Uniform.
We are going to assume, unless otherwise stated, but in this case, we are going to assume it is a uniform road. So where is the weight going to act? If the length of that road is 4 meters, where is it going to act from?
2 meters.
At 2 meters. So that point there, at 2 meters, we have the direction for the weight, the arrow for the weight. What was the tension? The tension was given. So what is the force for the tension?
40 newtons. 40 newtons.
The tension is 40 newtons. So can we get the directions?
We begin with the weight.
Let us look at the directions. Directions about the pivot.
Okay, in what direction?
Yeah?
We assume that this is the road, and we start with the weight. In which direction is the weight pull the road?
Anticlockwise. Anticlockwise.
Okay.
How about if we consider the 30 Newton force?
Clockwise.
Clockwise. Then we have the tension.
Anticlockwise.
Okay.
I
So
think those are the three.
now we have certain distances. Let us look at the distances. There are distances. Where is the pivot?
This one I've given as 0.2.
Okay. That's given as 0.2. Okay. Can we find now what we do? Sum clockwise moment is equal to?
And maybe before we get that, what distance is this?
Yes.
What small
What's the distance of the weight from the pivot? This what?
0.8.
Because from here up to here, halfway the meter road is 2. It also means that this other half of the meter road is 2 meters. So when you subtract 2 meters minus 1.2, you remain with 0.8.
Good. So 0.8 meters.
I think we have.
So now can we get the anticlockwise moment, sum of anticlockwise moments?
How do you go to 0.2 meters?
How do we get 0.2 meters? Somebody help us. How do we get the 0.8 meters, please? I hope that was the question. How do we get 0.8?
0.2.
Subtract 2 meters minus 1.2 meters.
You subtract what?
2 meters minus 1.2 meters.
1.2
meters minus 1.2. Maybe the person we want to understand why the 2 meters.
Because half of the metal road is 2 meters.
Half the meter rule is 2 meters. Yet the distance from the 2 meters pass to the point B is 2 meters. Yet they have given us a certain distance which is 1.2. So the remaining distance will be 2 minus 1.2, which gives us 0.8. So that when you add that total of 0.8 and 1.2, you should also get 2 meters, isn't it?
Yes.
Are we friends with 2K people now? Are we friends with the 2K students?
Not yet.
Not yet.
No.
Okay. You can,
Yes, we are.
when you are ready, you will tell me. I'm not selecting anybody from 2K.
How do you get 0.2?
But shared.
Nobody.
Joanna,
Yeah.
you want from 2S, tell us what to do. You want KW? Joanna's kept quiet.
40 newtons times 1 meter.
Well,
40 newtons times. Okay, yes, we're beginning with anti-clockwise moment. So the first anti-clockwise moment is the 40,
yeah.
I mean the force. 40 newtons, what is the distance between its direction of force and the pivot?
1.2.
So what should I write? 40 times.
40 times 1.2.
1.2.
Do we have any other anti-clockwise moment?
Yes.
No?
Yes.
That's
W
W
times
times what?
2.
times 0.8.
What is the distance of W from the pivot?
0.8.
0.8 meters.
0.8.
Then it should equal to the clockwise moment, which is equivalent to what?
30 times 0.2.
30 times 0.2. Okay, so if we work out quickly here, this is 48 plus 0.8 W, giving us 6. So if we are to
40.8.
We have a problem now. Distance
30 times.
So you solve these things.
And say you go to once in a year. Distance
Means this should be a
that weight
this one
is going to be this weight.
diagram.
In way what you call with that. Yeah. And divide to win the distance. We have a small challenge. It's a distance which was not given, but I think it is supposed to be more.
Even if you give it one.
Yeah.
Even if you give it one.
We are too small. Okay, let us work with the question. We shall work with its mistake. It is the only way we are going to get it because it doesn't make sense. It has a small error, but let us get the correct answer. We shall get other questions that are correct. So here we get 6. So what is our W?
6 minus 48.
Negative 42.
42.
42. So what is that? When you divide through, what did you get?
Negative 52.5.
Negative 52.5. Okay, the question had a mistake.
There was a distance which wasn't shown. We were just trying to.
Which we didn't notice when we were giving it to you. We just picked from the textbook, but the procedure is that. So even if it is an exam and there's a mistake, just work it out. The teacher will sort it out when they are marking, because the mistake is not yours.
The mistake is from the textbook.
Yeah.
Okay, but I hope we get the process of getting that solution. Now,
Teacher.
Yes, please.
So what if someone said 48 minus 6 is equal to 0.8 W? Why would that be wrong?
If somebody said,
if you said 48 minus 6, it means you'll have brought 6 negative, and then the 0.8 would become the negative. So you still get a negative.
Okay, thank you.
We are sorry about that. Yes.
Could I please know what distance was not given?
Okay, this distance here wasn't given, but even if it is given, the nature of the question, I think even if it is given, by the nature of the question, it would still be wrong.
Okay.
It doesn't matter whether what was given or not. The nature of the setting of the question was wrong. So you just have to follow correct procedure, but we can look at it. But it's just giving us practice. The basics are the same, okay? We are going to try to use questions in this document. I hope you have the notes, and then we look at something that we want to emphasize. We want to talk about reaction this time, okay? So let me share this document. You said it, we are the one who said it. So
Teacher, what page is that in the notes?
which page is this in our notes? Let me see the page number. Use the page number.
13.
You have seen that page.
13.
Eh?
Yes, thank you.
Okay. We are going to try to start working with the worked examples, then we shall progress with the examples that are not worked out. Altogether, let us start from the worked examples and then proceed because we are developing a concept. Are we clear, girls?
Yes, teacher.
Okay, if we are clear, let us start with that's the first question, I think. This is in a reaction. Okay, let us start from simple questions as we progress. Okay, so somebody read for us question 1.
Uniform meter rule balances horizontally.
I would very much like who is reading.
Teacher Tronila.
From 2K.
No.
Hey, I know you are from 2K. Sorry. S1, I mean question 1.
A uniform meter rule balances horizontally on a knife edge placed at 60 centimeters when 2 Newton weight is suspended at one end. A, with the help of a diagram shown at which end of the meter rule that 2 Newton weight must be suspended, calculate the weight, the mass of the meter rule, the reaction at the knife edge. Second,
okay,
is equal to 10 meters squared.
Now, let us look at that question carefully and we note the keywords. The first one is a uniform meter rule. I hope you know what that one means. Do you know what, when they tell us the word uniform, do you know what it means?
Yes.
Okay.
Yes.
And it is a uniform meter rule. How long is a meter rule?
100 centimeters.
Now, you see what they have drawn on the blackboard?
Yes.
You
Yes.
must get these skills. One end must be 0, one end must be 100. You must know that. Now, they have told us it is a uniform meter rule. Have they given us the mass of the meter rule?
No.
Read the question. You must know how to read the question. Have they given us the weight of the meter rule?
No.
No.
You see?
No, we don't have it.
No.
No.
We don't have it. Balances horizontally on a knife edge placed at the 60 centimeter mark. So they are going to show you what the 60 centimeter mark is. Look at the diagram and you see, because we are supposed to know how to draw these diagrams. So you select a 60 centimeter mark somewhere. Is that okay? And then there, what do we expect at the 60 centimeter mark?
The pivot reaction.
Pivot. So the pivot, it is pivoted at the 60 centimeter mark, the knife edge. So the knife edge is that simple triangle. Okay. And then when a 2 Newton weight is suspended at one end. So have they suggested which end?
No.
So that is your choice. Isn't it?
Yes.
Okay.
Yes, teacher.
So, we have not, but they say it's suspended at one end. So you selected an end. That is the question. Any end here. So we are selecting one end. And that end has been labeled, that's where the 2 Newton weight has been placed out together. So they are telling us with the help of a diagram, show at which end of the meter rule the 2 Newton weight must be suspended. So logically, there is a certain weight which must be acting at the center. Which weight is that? Which force is there at the center?
Weight. No weight.
The weight of the meter rule.
Wait.
Is that okay? So, if the weight of the whatever is there, where would you place the 2 Newton force? Because that was the question also. On which side would you place it? Because you have a pivot, you have a weight acting at the center. So which side would the weight be placed? The 2 Newton weight. On this side,
The right side.
On the right side. The side with 100.
On the side of 100. That is better answer. You know where to place it. The side of the 100 meter mark. So that the two are acting opposite. Is that okay? That is the logical solution for our 2 Newton weight. Is that okay? Yes. Now, the next question is to determine the weight.
Yes.
Can you tell us which distances we must determine?
Yes, teacher.
There is the Laula Nantumbo, is it? That's Nantumbo. Natumanya. I don't see the full name. So Laura, you are the one who has come up. Tell us what to do next.
I beg your pardon.
Laura, you want to make some rules in class. Nataona.
You find the distance between the pivot and the weight.
So what is that distance?
10 centimeters.
Good.
10.
Is another distance we must find?
The distance between the pivot and 2 Newtons.
What distance is that?
40 centimeters.
Good. Okay. Now, we are supposed to find the weight of the meter. What we do?
Excuse me, teacher.
Yes.
Teacher, I thought we were for finding where the 2 Newton weight must be suspended. I thought we just found the side, not the point. So how do you just get not necessarily 40 centimeters, but something above that is above?
What? You read the question.
With the help of that,
when a 2 Newton weight is suspended at one end,
it is specified.
So it is one end. Logically, which end? Asking you which end.
Yes.
So you know that if there is a weight, there is a 2 Newton force which must be suspended from one end. So if the weight is acting from the center, where would you put the 2 Newton end? At the 0 centimeter mark or the 100 centimeter mark? For you to balance. Yeah?
At 100.
Why?
Because they say that one end.
At one end.
That's not the question.
That's the thing to do since there's already a.
What would happen if first said the 0 mark?
There is already.
Already a first said that is a logical chapter.
Okay, one person at a time. Noella?
Some idea the question, people over talk.
Yes, Noella has the floor. No,
Yes.
why shouldn't we put the 2 Newton force at the zero end?
Teacher, because there is already a force acting on that side. So put
if
it
you
on
put
the
it
other
here, what
side.
will happen?
The meter rule won't be balancing.
It will fall to the left side.
So
my question was,
if they are on the same side of the pivot.
She has a question.
So my question was, if they say one end, does it mean it has to be either at 0 or 100, or we just make it on the other side, somewhere on the other side, or it has to be necessarily at the end of the meter rule?
Okay, when they say at one end, it has to be at one of the ends, either at 0 or at 100. Then you look at the position of the weight, just like you've told us. If we put it at 0, the ruler will not balance, it will topple, okay, or it will fall on the left-hand side. So the only other end that we're supposed to put it is at the 100 centimeter mark. But it was specific at the end.
Thank you, teacher.
Okay, thank you. I hope those observations are made. The first thing we did was to label the marks 0, 50, 60, 100. Then we identified where the weight should be acting from. Then we know by common sense, with these forces that balance and they are rotating about the same pivot, then automatically they should be on opposite sides of the pivot. That is the logic, isn't it?
Yes.
Okay, now the weight, can we find the weight?
Okay, so which type of moment would the weight bring about the pivot?
Anticlockwise.
Anticlockwise.
How about the 2 Newton?
Clockwise.
Clockwise. Newton or clockwise? Okay, so using our second condition, that's anti-clockwise moment. Please practice writing this in full. When you just write ACW, it can mean anything. Arsenal, Chelsea, and which other team is that? Okay, so please write them in. Sam, sorry, Sam. Equal to the sum of clockwise moment. So the sum of anti-clockwise moment should equal to the sum of clockwise moments at the same point. And this time, our point is at the pivot here. So we've identified the force that causes the anti-clockwise moment as W. So what will the moment be?
W times 10 centimeters.
Being equal to.
Times 40.
Times 40. Divide by 10. And what's our weight?
8 Newton.
8 Newton.
8 Newton.
So we finished with Roman 1, I think, of the question.
Roman 2 is asking mass of the meter rule.
If the weight is 8 newtons, what would be the mass?
8 divided by
80.
How do you find the mass?
divide by 10.
Divide by 10. We are using the formula weight is equal to mg. Weight is 8. Then the g is 10. So that is how people are concluding this divided by 10. And therefore our mass is
0.8 kilograms.
Kilograms. Very good.
Okay, 2K you are forgiven. You can also contribute.
Thank you, teacher.
How did you do?
Roman 3, Roman 3, what is Roman 3 asking this time?
The reaction at the knife edge.
Asking us for reaction. Is that okay? Now, where does a reaction force act?
The opposite.
Let us be very specific. Where does a reaction force act? At the pivot. Answer at the pivot. I want you to tell me why at the pivot.
That's where the weight is concentrated.
That is where what?
The weight is concentrated.
The weight is being balanced.
No, the weight is concentrated at the center of gravity. Now this is reaction force. Where is the reaction force concentrated? Where is at the pivot?
There's a force up and down.
That's where the weight is.
That is where the what?
The meter balance.
Oh, the meter
No, not the meter rule balancing. It's not about balancing.
That's where all the weight on the meter rule balances.
No.
Some of the forces. Because it supports the weight.
The weight of the forces are concentrated. Look at the ruler. Look at the ruler I'm supporting. Suppose I remove my hand, what would happen?
To fall.
To fall. So what is my hand doing? My finger, what is it doing?
Balancing the ruler.
I want one correct word. It is the one that is doing what?
Supporting the meter.
Supporting. Where the weight or the weights are supported. Is that okay? That is where our support is. So this body matters, it has its weight, but it is only supported at the pivot. And they remember that the reaction will now occur at the pivot, at the point of support.
Yes.
Is that okay?
Yes.
So you must understand that reactions will only occur where the supports are. Are we clear?
Yes.
Okay. Now apply the first tip rule for equilibrium to occur. What was it? What was the second condition? The first condition for equilibrium?
The sum of forces in one direction is
Forces in one direction.
of forces in one direction is the opposite forces.
Please, don't know whether it is in from Rhoda or whatever, but we have a choir here. I'm selecting Namgabo. Namgabo, tell us.
Sum of upward forces equal to
Sum of upward forces
in one direction. Sum of downward forces.
Okay. Sum of forces acting in one direction. Sum of forces acting in one direction
is equal to sum of forces acting in the opposite direction.
Okay. So you must be very specific about the condition. The condition should not be upward forces, but here it is okay. That I don't know.
How many forces we have action?
One. The reaction.
The reaction.
Body is too far.
The reaction.
The reaction
Is equal to?
Is equal to W plus 2N.
That's 2N. We've already found out that
W was 8N.
8 newtons.
Therefore, what is R?
R is equal to 10 Newton.
Very beautiful. So that is your first question, and we are talking about the reaction now. So we have pointed out that please we expect the reactions. Where do they act? From which points do they act?
At the pivot.
Pivot.
At the pivot.
No.
At the point of support.
At the point of support. The support can be a pivot. The support can be some support to be. You must be a string. That's very good. Okay. Yeah. Supports still have. That's why. I hope you're together. At supports. Okay. I think that's what that was the first.
Teacher, excuse me.
Yes, please.
I'm confused. What if there is the pivot and a string? So which one is that?
That is where, so that is our next question. There is a pivot and a string. Isn't that your question?
Yes.
So look at question 3 and take B. Read question 3. You are going to answer that question. Guide us. Yeah? Read question 3. We are answering your question.
Oh, okay. The figure shows a uniform horizontal bar supported by a peg P and spring balance S. The spring balance reads 10 newtons. Find the weight of the bar and the reaction of the peg.
That is it. The diagram was given. So we are going to try to answer, much as they are talking about a spring balance, but the spring balance actually has tension in it. Okay? So this time the diagram was given, so we are simply representing it, and you're going to tell us what happened. We have the pivot.
Yeah, no, you're going to force there on ground. So just indicate forces, not your what the cross like that. Go force there ground, indicating other forces. And you can have
Suppose. We are. Do you see what we have done here? Can you tell us what we have done here? Have you seen what we have done?
Can I mute?
Cynthia, you're making noise for us.
Okay, do you see what we have done here? We have changed this diagram slightly from the one that you have. We have drawn lines. I think you are seeing these lines because we use lines and arrows to indicate the force that is acting there. Are we together, girls?
Yes.
Now look carefully. There is a word there. The figure shows a uniform horizontal bar. Is that okay?
Yeah.
Yes.
Yes.
Now, how long is this bar? Add those values. 100. If it's uniform, where does its weight act from?
50 centimeters. 50 centimeters.
So how are you going to locate the 50?
W.
Maybe it's around 7.
Okay. Now let us help you. From here to here, what is that?
Yeah.
What have I put?
10.
I put 10. What have I put?
0.
0.
So how long is the meter rule?
100.
100. From here to here, it is what?
10. meters.
Then from here to here, the weight, what should it be?
70.
40. All the way from here, all the way from
All the
zero.
way from here.
50.
Here.
50.
So if we have the first 10, I hope you're together. How much are you ending with?
40.
40. Very good. Now, from here to here, what will this be?
20.
What mark should this be?
20.
80.
80. Very good. So remember that this is 50. So what is this distance here?
30.
30.
Now you have got the distances. Very well. Have you seen how you have got the distances?
Yes.
I hope everybody has figured out where the distances, because that's where the tricky part is.
I cannot see the chalkboard clearly.
Cannot see what?
There is a network.
Have you seen the chalkboard now?
Yes.
Any questions before we move on? Regarding the 10, the 30, the 40? Looks like there are no questions.
Okay.
Is it
So,
necessary?
is it necessary to?
Who told that?
Is it necessary to put all this?
So
That's the question.
suppose it wasn't necessary, how would you locate the distances? Can you guide us on how we find the distances without this being necessary? You guide us. For us, we are removing what is not necessary. Now tell us, what will we do?
Everything.
We have removed everything. Now you guide
You are
us.
wondering whether
We are wondering whether it is necessary or not. We are answering your question.
Yes.
Okay, tell us what to do.
We laugh.
I think she has
Okay,
accepted.
I think we have got the point. If you haven't, I don't know, but for us, we consider it necessary. We have looked at the information given, and that's the only way we can determine the distances. Okay, we have labeled this as 100, we have this to be an 80 centimeter mark, we have labeled this to be a 50 centimeter mark, this is a 10 centimeter mark, this is 0, and now we are able to find our distances. Okay?
Yeah.
Okay, can we now move on?
What type of moment does the W bring about?
As what?
Clockwise.
What type of moment? Clockwise or anti-clockwise?
Clockwise.
Okay, at what point are we taking our moments about? We have 2 points. We can take the moments about this point, or we can take them about this point.
There are two support systems this time. There is a pivot and there is this spring. Those are supports. And that's where the moments can be taken from. So which position are we taking moments from? Can you tell us? About the pivot.
Okay, if we are taking moments about this point, what type of moment does the weight produce?
Clockwise.
Which other force is active on the meter? And what is the direction of the moment?
Anticlockwise. Anticlockwise.
S is 10. Call it S. 10.
Okay, so taking moments about the pivot.
So we're taking moments about the pivot, and there is the sum of anti-clockwise moments.
Yes, that arrow.
So our anti-clockwise moment, we've identified, if you notice, I've changed this to T. The S was the spring, the spring was called S, or was labeled S. But when you decide to represent the tension, then we use T for tension. And it was given as 10 newtons. So what is the distance of T, which is 10, from the pivot?
70.
70
centimeters.
Okay. How did you get the 70? It was already given.
Yes.
Should equal to, what is our clockwise moment?
W times 40 centimeters.
So whoever was wondering why we were doing all this, we were trying to identify the 40 here. So we have 700, or I begin with this side, 40W. 700.
700 divided by 40 on both sides.
What we get?
W is equal to 17.5 newtons. 17.5 newtons.
Okay. So we have found the W. The next question is asking us to find the what?
What is Roman?
Find the reaction of the pig.
Find the weight.
Hey, somebody is not concentrating.
Someone is still on Roman.
Rotating, but not concentrating.
The reaction of the pig.
So the reaction is R. That is, it is a support the peg. Okay. So we have that reaction shown and is acting in that direction. Okay. So now what do?
Forces in one direction equal to sum of forces in the opposite direction.
R plus S is equal to
sum of forces acting in one direction is equal to
Sum of forces acting in the opposite direction.
So in this case, I have the sum of forces in the upward direction.
It's equal to sum of forces in the downward direction.
Okay, so what do we have in the upward direction?
R plus 10 newtons.
Reaction. R plus 10 newtons. Let's first write it as R plus T is equal to?
W.
And substitute.
So now when we go to substitute, our T is 10. W, just found W as 17.5. Okay, so if we rearrange, our R will be 17.5 minus 10, giving us R as
7.5 newtons.
7.5 newtons. 7.5 newtons.
Okay. Okay, we are remaining with only 2 minutes.
I don't know that our host will be generous with a little bit of some 5 minutes. And we do this question. This question, the last one here.
Teacher is not on.
What this is this? Our
general response.
Chabato. Chabato is always very generous. Let us question. Mr. Bato is very generous. We are doing question 3. You read question 3.
Very generous.
A silence means it.
Silence, and especially 2K keep quiet. Silence.
Oh, yeah.
1, 2.
We are
What
going
did
to
you
be
ask
very
you?
fast with this question because of the time. Okay, someone take us through the question, read for us the question.
A diagram shows a uniform bar of weight 0.8 Newton resting on pegs A and B.
Okay, so this time around we have a question with two supports, but both of them are pivots compared to the previous one where we had a pivot and a string. Okay, so we are going to indicate it's a uniform. Let's indicate the given forces. So I'll first indicate the pivot. That is the first one, and then we have the second one. Okay, let's indicate the given forces. The question gave us 10 newtons at 10 centimeters. At 10 newtons, and the distance from the end is 10 meters. Is at 10 centimeters. The other force given is 6 newtons at the end. And then putting these distances, the pivot at the distance between the 10 Newton and this is A, B. So the distance between this and this was given as 70. All this is given information. So this is 70 centimeters, and then we are given 20 centimeters. So all this is given information, okay? All right, so we want to now interpret this question. It says the diagram shows a uniform bar of weight 0.8. Who can tell us where we're going to locate that weight?
Angel, Namara. Hey, Namara, tell us where we put the weight. Angel, tell you. Mulungi.
In the center.
At the center. At the center, okay? So the center is where we're going to be approximately the center. That's why we're going to put 0.8 newtons. In the question, they didn't indicate it, but use your knowledge to indicate. So this means it is at 50 centimeter mark, okay? So I think that's all. The question says, find a reaction at each page. So there's a reaction at this point, which I've discovered in Mr. Senjo and Chajavi where we put it. So this is, shall call it RA, and then we shall also have RB. Okay, so just like we had supports in the previous example, we also have two supports, and it shows one support, one point of support to be a point where you take your moment. So we're going to choose a point A. Okay, you can choose any point. What you call the distance, and what you call the distance, and what you call so we define a point which is a average, so we can this one. Okay, so let's quickly get a reaction. We are going to, let's take moments about point B. Okay, so taking moments. Value 159.
I think it's
lunch and use to support your account.
Okay, you try it out. We shall begin from there.
Hello, girls.
Yes.
Yes, teacher. Isn't ready?
Some people have left.
Some people are leaving the room and you don't see any reason to continue because you are going to be losing out. But as we are suggesting, we leave the question, we shall start with that question next time.
Yes.
You can give it a try,
but give it a try. Take moments about point B. For me, I'll be ready to receive those.
Teacher, you only in case class.
Teacher.
Yes.
Is it? I had a question. Will the reaction first be the same?
Yes, teacher. Yes,
okay,
sir.
question.
They could, we don't know.
So is it a cumulative reaction or I can just
Because they said they wanted you to find the reaction on the pig, but if we use the weight we found for taking moments about the pig, and we use that weight to find the reaction on the on the tension on the spring balance, would we have got the same thing?
If we took moments about the spring balance, we would get the same answers.
Okay.
Okay, our friends, those who would like to try out, take moments about point B. And then you find RA using the second condition. Okay, then to get, since now you'll be having RA, you'll use the first condition which says some of the forces acting in one direction is equal to some of the forces acting in the opposite direction, which will be RA plus RB equal to 0.8. So you try it out. The total downward forces, I beg your pardon. According to that first condition, the sum of the forces acting in one direction is equal to the sum of the forces acting in the opposite direction. So R plus R will be equal to 10 plus 0.8 plus 6 newtons. We'll give it a try. We'll start from there because most of your friends have already left, and it will be unfair for us to go through when they are not in class.
It's unfair when them to leave.
Let them go.
Bye. Bye. Enjoy your lunch.
Bye, teacher.
Bye, teacher.
Bye. Thank you for the lesson.
It's big brother. Bye.
Bye. Adios,
Bye to AC.
Even to NPS.
Hello to our class teacher to tell us bye.
Banana. Bye, teacher.
Bye-bye.
Bye.
Have a nice lunch.
Bye, please.
There is not two case.
Why you say someone everyone should come?
Bye.